Good afternoon, guys. Are you getting my voice? Are you getting my voice? Guys, are you getting my voice? Okay. Till only 11 members join here. We will wait for 1 more minute for the people. Okay, guys, we will start. Remaining people will join the mill. I hope my voice is okay for you. See, today we are going to see the last unit of the compiler design, that is machine independent optimization. Our last topic of the sixth CD subject is the machine independent optimizations. What is meant by optimization? Code optimization. What is meant by the code optimization? Optimization means improving the code or making modifications to the code. Clear? Optimizing means bettering of the code is called optimization. Generally, మీకు డాలో వచ్చింటుందండి. Optimal solution means best solution. Okay, the better solution is called the optimal solution. Similarly, here also code optimization means we are modifying the code to get the better one, to make it as much as better. We are modifying the code. That is called the code optimization. Clear? When we come to the today's unit, is last unit, that is the machine independent optimizations. Clear? We will briefly see about this one. What is this machine independent optimizations? How it will be performed? See, the first part, the slide is the introduction. Is about introduction. Okay. Generally, high level language constructs means programming statements. High level language constructs. Constructs means nothing but the programming statements. Okay, when we come to the high level constructs, okay, high level language constructs can introduce substantial runtime overhead if we naively translate each construct independently into the machine code. Okay, మన సోర్స్ లాంగ్వేజ్ హై లెవెల్ లాంగ్వేజ్లో ఉన్నటువంటి కన్స్ట్రక్ట్ మీన్స్ ప్రోగ్రామింగ్ పార్ట్స్. ఫర్ ఎగ్జాంపుల్ ఒక ఫర్ లూప్ ఉంది, ఒక ఇఫ్ స్టేట్మెంట్ ఉంది, ప్రోగ్రామ్లో ఒక ఫంక్షన్ ఉంది. Okay, all those are called the constructs. If the high level language constructs can, they will create overhead, runtime overhead, if they are if each of them is independently translated into the machine code. Okay, instead of translating them combinedly, if we can translate them independently, the for loop is converted to machine code. Next, the function is converted to machine code. Next, The if statement is converted to machine code. Like that, if the programming constructs are individually converted into the machine code, then they will create the runtime overhead. They will create the time of running of the program. They will create the problems. If the programming language, high level programming language constructs are translated into the machine code individually, okay, independently, without any relation with other. For example, we have the for loop. We convert the for loop into the machine code without checking whether the for loop has any relation with above code or below lines, whether it has any relation with any part of the program. If the function is converted into the machine code without independently, without checking whether the function has any other relation with any other functions, okay, that type of translation of the high level constructs into the machine code independently will create the runtime problems. At the time of running of the program, they will generate the overhead. Elimination of unnecessary instructions in the object code or replacement of one sequence of instructions by a faster sequence of instructions is called code improvement or code optimization. What is our code improvement or code optimization means? What is our code elimination of unnecessary instructions. Whenever there are unnecessary statements are there in the program, elimination of unnecessary statements from the program or replacement of one set of instructions with another faster set of instructions. One sequence of instructions are there, they will be replaced with a faster sequence of instructions. That type of modification is called the code improvement or code optimization. How can we define the code improvement or code optimization? Means this is the way how to define that one. Clear. Elimination of unnecessary instructions in the object code or replacement of one sequence of instructions by a faster sequence of instructions that does the same thing is called code improvement or code optimization. సేమ్ వర్క్ చేసే ఒక స్టేట్మెంట్ని సేమ్ వర్క్ చేసి ఇంకో స్టేట్మెంట్తో రీప్లేస్ చేసాం అనుకోండి, ఇట్ ఈస్ కాల్డ్ కోడ్ ఇంప్రూవ్మెంట్ ఆర్ కోడ్ ఆప్టిమైజేషన్. అవసరం లేని లైన్స్ డిలీట్ చేయడం కానివ్వండి, ఉన్న లైన్స్ని సేమ్ వర్క్ చేసే ఫాస్టర్ లైన్స్ తోటి ఇఫ్ యూ రీప్లేస్ దేమ్, the type of modifications is called code improvement or code optimization, which is our topic. Clear. Now the principal sources of optimization. The first topic here is the principal sources of optimization. Clear. ఏ కం ఎవరండి మ్యూట్ అవ్వాలి? హూ ఇస్ దట్ పర్సన్? A compiler optimization must preserve the semantics of the original program. Okay, a compiler optimization, whenever a compiler performs the optimization of the code, it must preserve the semantics of the original program. Semantics means meaning of the original program. Whatever the meaning of the original program, that meaning should not be changed. For example, your program is area of a square. We have to read an integer number and we have to find area of a square. So the main theme of the program is we have to read an integer number from the keyboard and we have to find area of a square. That semantic should not be changed. Here semantics means overall meaning of the program should not be changed. Our aim, whatever our aim should not be disturbed. Without disturbing our aim, okay, the compiler optimization must preserve the semantics of the original program. That means it has to preserve means it has to keep safe the semantics of the original program while making modifications or improvements. Except in very special circumstances, except in special situations, once a programmer chooses and implements an algorithm, the compiler does not understand enough about the program to replace with it with a substantially different and more efficient algorithm. That means, okay, except in very special cases, generally when a programmer selects and implements a algorithm, the compiler will not touch that algorithm. It won't replace that algorithm with another algorithm. The compiler will not see that algorithm and it won't try to replace that algorithm with another different algorithm. Okay, except in some special cases, generally once a programmer chooses and implements a particular algorithm, the compiler will not try to change that algorithm. It won't try to replace that algorithm with another algorithm. Okay, only in special circumstances only the compiler will try to replace the algorithm chosen by the programmer with another algorithm. Clear. Once we decided to find to follow some logic, that logic will never touched by the compiler. The compiler will never replace that logic. The overall logic will not be changed by the compiler. Whatever we selected by the user, that logic will not be changed. Okay, it will touch the overall logic or algorithm only in special cases. Clear? What a compiler knows is a compiler knows only how to apply relatively low level semantic transformations. Compiler తెలిసిన ఆప్టిమైజేషన్ ఏంటంటే వాట్ ఇట్ విల్ నో ఇస్ ద it will know only to how to apply the low level transformation semantic transform. That means what it knows is only it will know about the how to transform the smaller statements, only it will know. Like for example, if there is a statement I plus 0 is equal to I, okay, the compiler can understand this statement is not required, so it will eliminate I plus 0 is equal to I. Like that, only it knows how to modify the low level statements, only how to modify the small statements. It doesn't know how to modify the entire algorithm, how to replace the entire algorithm. Okay, the compiler while performing optimizations, it don't touch the entire algorithm of the program. Only it will try to modify the smaller statements of the program. It will take each individual statement and it will try to, is there any possibility of improvement of the code in this statement, it will improve that code. Like that only it will do. It don't try to modify the change the overall algorithm whatever we want to select, whatever we have selected. That is the thing. Generally, where we perform the code optimization means the code optimization is performed in the synthesis phase of the program. Okay, in the compiler design we have two phases are there: analysis phase, synthesis phase. The synthesis phase contains the intermediate code, code optimization, target code generation. Okay, this code optimization is present in the synthesis phase. Okay, in the synthesis phase is a program transformation technique which tries to improve the intermediate code by making it consume fewer resources so that faster running machine code will result. See this one. What is this code optimization? He is one more time he is trying to define the code optimization. Okay, the code optimization in the synthesis phase is a program transformation technique which tries to improve the intermediate code by making it consume fewer resources. We will try to improve the intermediate code so that it will take less resources. That means less CPU time, less amount of memory, so that faster running machine code will result. Okay, we have to replace the intermediate code with with a new code that will require few resources and which can run fastly. That is the one more definition of the code optimization. In the synthesis phase is a program transformation technique which tries to improve the intermediate code by making it consume very few resources like CPU time or memory, so that faster running machine code will result. Clear? This is briefly the first thing. What are the principal sources of optimization? The introduction in this optimization is code optimization must preserve the semantics of the original language. Generally, compiler doesn't know how to replace the algorithm. Whenever an algorithm is selected by the programmer, the compiler will not modify that algorithm. Okay, only in special cases compiler will try to modify the algorithm. The overall algorithm will not be modified by the compiler in general. Only it will try to modify the apply transformations to low level statements. That means for small statements of the program only it will try to apply the transformations, like the statements I plus 0 is equal to I, etc. Okay, here the code optimization can be defined as improving the intermediate code by making it consume fewer resources so that faster running machine code will result. ఎవరండి అన్మ్యూట్ అయింది? Okay, the compiler optimization process should Meet the following objective. There are some conditions that must be satisfied for compiler optimization. Compiler optimization process should meet the following objectives. What are those objectives? The optimization must be correct. The optimization must be correct. It must not in any way change the meaning of the program. Whatever the optimization we are going to apply, it should not change meaning of the program. The overall meaning, that means the semantics of the program should not be changed. Okay, the optimization, the first condition that must be met for applying compiler optimization is the optimization technique we are applying must be correct. It should must not in any way change the meaning of the program. The optimization should increase the speed and performance of the program. Whatever the optimization we have done, it should increase the speed and performance of the program. Our aim of optimization is only to increase the speed and performance of the program. Okay, the compilation time must be kept reasonable. The overall compilation time must be reasonable time. You should not take huge amount of time for compilation. The overall compilation time must be a reasonable one. The optimization process should not delay the overall compilation process. Whatever the optimization process we have selected, it should not delay, it should not affect the overall compiling process. That means the optimization process should not take huge amount of time. Whatever the optimization technique we have selected, that optimization technique should not affect the overall compilation process speed. It should not take huge amount of time. These are the some important objectives that must be satisfied for applying while applying the code optimization. The first one is the optimization should not change the meaning of the program. Optimization should increase the speed and performance of the program. The compilation time should be kept reasonable. It give only a reasonable compilation time. The optimization process should not delay the overall compilation process. The optimization process should not affect the overall compilation process. These are the conditions or objectives that must be satisfied while applying the compiler optimization. When to optimize? Okay, when we are while in the compilation process, when we have to optimize. Generally, optimization of the code is performed at the end of the development stage. That means after the entire source code is ready, after the complete source code is ready, then only the optimization of the code is performed. Optimization technique is applied only at the end of the development stage. That means code development stage. After the code is developed, then only optimization of that code will be applied so that it reduces the readability and adds code that is used to increase the performance. Okay. By doing the optimization at the end of the development stage, it reduces readability. Okay, we have no need to worry every time whether these lines are depending on any other lines. And also, it will increase the performance. Okay, the code can be successfully replaced with another code that will increase the performance. Okay, so what is the preferable time means? After the source code is ready, it is preferable to apply optimization instead of while writing the source program. Some persons will try to improve the code at the time of writing of the program itself, but it is not a good idea. After the total program is ready, it is better to optimize the program. Why optimize? Why we need to optimize the program? What is the necessity of optimizing the program? Optimizing an algorithm is beyond the scope of the code optimization phase. Generally, optimization of algorithm is not possible by the code optimization technique. Okay, at the time of algorithm phase itself, we are unable to optimize the algorithm. Whatever the logic we have selected, we can't apply the optimization on algorithms. That's why the program is optimized. After the complete program is ready, optimization is applied. And also by applying the optimization on the source code, it may reduce the size of the source code. We may reduce the size of the source code by applying optimization on the source code. So why optimization is applied on the source code means, okay, optimization is not possible on the algorithm, that's why optimization is applied on the source code. Okay, and also applying optimization on the source code will reduce the size of the source code. There are two questions: when to optimize, why we have to optimize. Generally, optimization helps to reduce the consumed and also increases the speed of compilation. Why we need to optimize means, if we perform optimization, it reduces the space complexity. The amount of space required for running the program is reduced, and also it increases the speed of compilation. That is the one reason why we need to optimize the code. Okay, next, manually performing the optimization is also tedious, means very tough, and it is better to done using a code optimizer. Okay, manually improving the code. Manually, the programmer will sit on the program and he will try to improve the code. But the task is a tedious process. By taking the source code, if you try to modify the code, improve the code, by taking the source code, we may sit and we can improve the source code. We may successfully improve the source code, but it is a time taking process. So the better idea is to use the code optimizer. Simply the source code will be given to the code optimizer. It will automatically improve the code, and the final optimized code will be given to the code generator. The final optimized code will be given to the code generator. Clear? The manual process is very tough one, that's why it is preferable to do the optimization using the code optimizer. And also, an optimized code often promotes reusability. Okay, one more advantage why we need to code optimization is, an optimized code often promotes reusability. Reusability will be increased in the optimized code. I will show you later how reusability is increased. Okay, this is the reason when to optimize. After the development stage, it is better to optimize the code after the development stage. That means after complete development of the source code, it is better to apply the optimization. Clear? Why we need to optimize? Generally, optimization of algorithm is not possible, that's why source code is optimized. Okay, if we optimize the source code, the following are the benefits: it will reduce the space required. That means the size of the program will be reduced, so that the space consumed will be reduced, and also it will increase the speed of compilation. How much space required will be reduced, and speed of execution will be increased. Will be increased. Next, the optimized code often promotes reusability. That means the optimized code will support the code reusability. And the third point is, manually performing the optimization is a tough process. That's why performing of the code optimization using the code optimizer is preferable one. Performing of code optimization using the code optimizer is a preferable one. These are the two things: why, when to optimize, and why to optimize. Whenever we have those two questions, this is the answer for those two questions. Next, where to apply optimization. Optimization techniques ఎక్కడెక్కడ అప్లై చేయాలి? Where to apply the optimization? Okay, we can apply the optimization directly on the source program. One location where we can apply the optimization is, we can apply the optimization directly on the source program. Optimizing the source program involves making changes to the algorithm or changing the loop structures. Changing of the loop structures or changing of the algorithm is the optimization of source program. Here, who is the actor here means user is the actor here. That means who will perform optimization on the source program? The optimization of the source program is done by the user only. User will perform the optimization of source program. We can also optimize the intermediate code also. We can also optimize the intermediate code. Optimizing the intermediate code involves changing the address calculations and transforming procedure calls involved. Who will do this work means compiler is the actor here. That means compiler will do those modifications. Intermediate code optimization can also be performed. The intermediate code, if the source code is not optimized, we can perform optimization at the intermediate code also. In case of intermediate code optimization, it involves changing of the addressing locations, transforming the procedure calls involved, etc. All those things will be done in the intermediate code optimization. Here, who will do this work means compiler will do this work. Finally, one more location where to apply optimization is we can apply transformations or optimizations on target code also. Okay. Optimizing the target code is also done by the compiler. This work will also be done by the compiler only. Usage of registers, select and move instructions is a part of optimization in the target code. Okay. In case of target code optimization means, okay, the compiler will try to use the more number of registers. Okay, it will try to use the more number of registers, select operations, move operations, etc. Okay, so finally, where to apply the optimization means we can apply optimization on source code, but this optimization is done by the user. We can perform optimization on the intermediate code, or we can perform optimization on the machine code, either on the target code or on the intermediate code or on the source program. In all these three locations, wherever we want, we can apply the optimization in all the locations wherever we want. Clear? Next concept is the phases of optimization. What are the phases of optimization? When we come to the phases of optimization, there are two phases of optimization are there. Global optimization, local optimization. Can anyone define what is local optimization? What is global optimization? Can anyone define that one? What is the global optimization and what is the local optimization? Local optimization means, I think already we have covered the topic of basic blocks, how to divide the intermediate code into basic blocks. After the code is divided into the basic blocks, if the optimization is done within the block, it is within the basic block, it is called local optimization. Okay, if the optimization is performed within the basic block, it is called as local optimization. While performing local optimization, it will consider only the statements within that basic block. ఆ బేసిక్ బ్లాక్ లో స్టేట్మెంట్స్ మాత్రమే కన్సిడర్ చేసి ఆప్టిమైజేషన్ చేస్తే ఇట్ ఈస్ కాల్డ్ లోకల్ ఆప్టిమైజేషన్. వెన్ ఎవర్ ద ఆప్టిమైజేషన్ ఈస్ పర్ఫార్మ్డ్ బై కన్సిడరింగ్ ద ఎంటైర్ ప్రోగ్రామ్, ఆల్ ద స్టేట్మెంట్స్ ఆఫ్ ద ప్రోగ్రామ్, ద టైప్ ఆఫ్ ఆప్టిమైజేషన్ ఈస్ కాల్డ్ ద గ్లోబల్ ఆప్టిమైజేషన్. Clear? Global optimization means applying optimization by considering all the statements of the program, entire program. It is called global optimization. If you perform the optimization by considering only the local statements of the basic block, the type of optimization is called the local optimization. Again, this topic will come as types of transformations. Okay, transformations are applied to large program segment that include functions, procedure, loops. Okay, if the transformations are applied to a large program that includes functions, procedure, loops, if the transformation is applied on the entire program, it is called global optimization. If the transformation is applied on the entire program, it is known as global optimization. What is local optimization? Transformations are applied to small blocks of statements. Okay, whenever the transformations are applied to statements of the basic blocks, the type of transformation is called the local optimization. వాయిస్ లోగా వస్తుందండి. ఈజ్ ఇట్ టూ లో మై వాయిస్? మ్యాక్సిమం వాయిసే ఉందండి ఇక్కడ కూడా. ఐఎమ్ హెల్ప్లెస్. నా దగ్గర అయితే మ్యాక్సిమం వాయిసే ఉంది. ఓకే, సి. So local optimization and global optimization, two phases are there in case of optimizations. What is global optimization means? If you apply the transformation on the entire program, that means by considering all the statements of the program, if you apply transformation, that is called global transformation. If you apply transformation only basing on the statements of the basic block, only by considering small blocks of statements. That means if you after dividing the three address code into basic blocks, if you apply transformation only by considering the statements within that block, that type of transformation is called the local optimization. Generally, when we come to the local optimization, global optimization, first we will try to prefer the local optimization. After local optimization, global optimization will be preferred. After the three address code is divided into the basic blocks, on each block first we will apply the local optimization. After local optimization is over, we will prefer to apply the global optimization. Clear? That is the types of optimizations, sorry, phases of optimizations: global optimization and local optimization. Next, types of code optimization. What are the various types of code optimizations? The optimization process can be divided into two types. First one is machine independent optimization. Second one is machine dependent optimization. When we come to the types of code optimization, it can be broadly divided into two types: machine independent optimization, machine dependent optimization. Can anyone define what is machine independent optimization? What is machine dependent optimization? ఎవరైనా డిఫైన్ చేయగలరండి ఎలా ఉంటుంది? What is machine independent optimization? What is machine dependent optimization? మెషిన్ ఇండిపెండెంట్ ఆప్టిమైజేషన్ అంటే ఎలా ఉంటుందండి? కొంచెం అలాగే అండి, మరీ ఎగ్జాక్ట్లీ మీరు చెప్పింది కాదు. ఇంకెవరైనా? మీరు చెప్పింది కొంతవరకు ఓకే కానీ నాట్ కంప్లీట్లీ దట్ వన్. See, here machine independent optimization means, generally what is optimization here? Improving of the code is called optimization. Transforming of the code is called optimization. While transforming the code, if you don't consider the machine, if you don't consider the machine instructions or machine registers, the type of optimization is called machine independent optimization. For example, while we are improving the కోడ్ ఇంప్రూవ్ చేసేటప్పుడు ఓకే, ఆ మెషిన్ ఇన్స్ట్రక్షన్స్ కానివ్వండి, అడ్రస్సింగ్ మోడ్స్ కానివ్వండి, రిజిస్టర్స్ కానివ్వండి, మెషిన్కి సంబంధించిన ఏవి కన్సిడర్ చేయకుండా ఓన్లీ సోర్స్ కోడ్ మాత్రమే లాంగ్వేజ్లో లాంగ్వేజ్ని మాత్రం అప్లోడ్ ఇది ట్రాన్స్ఫార్మ్ చేస్తే ద టైప్ ఆఫ్ ఆప్టిమైజేషన్ ఈజ్ కాల్డ్ మెషిన్ ఇండిపెండెంట్ optimization. While we are modifying the code, we will consider only the programming language constructs. We don't consider the machine. Okay, మెషిన్ అడ్రసింగ్ మోడ్స్ కానివ్వండి, మెషిన్ రిజిస్టర్స్ కానివ్వండి, మెషిన్ యొక్క ఇన్స్ట్రక్షన్ సెట్ కానివ్వండి, వీ డోంట్ కన్సిడర్ ఎనీథింగ్ విచ్ ఈస్ రిలేటెడ్ టు ద మెషిన్. వీ విల్ కన్సిడర్ ఓన్లీ ద లాంగ్వేజ్. Okay, we take the language statements and we will try to apply that one optimization on those language statements irrespective of the machine code or machine, irrespective of the machine instructions or machine registers. That type of optimization is called machine independent optimization. When we come to the machine dependent optimization, how can we define the machine dependent optimization? Means, while we are optimizing the source code, while we are optimizing the source code or intermediate code or target code, we will consider the machine instructions or machine registers. We will consider the machine instructions or machine registers. That type of optimization is called machine dependent optimization. అంటే మెషిన్ డిపెండెంట్ ఆప్టిమైజేషన్ ఎలా ఉంటుందంటండి, ఒక ఇన్స్ట్రక్షన్ ఉందనుకోండి, ఆ ఇన్స్ట్రక్షన్ని వేరే ఇన్స్ట్రక్షన్తో రీప్లేస్ చేయొచ్చా చెక్ చేసుకుంటాము. ఇన్స్ట్రక్షన్ సెట్ ఆఫ్ మెషిన్లో ఇంకేదన్నా ఇన్స్ట్రక్షన్ ఉందా సేమ్ వర్క్ పర్ఫామ్ చేసేది, దీనికంటే ఫాస్ట్గా సేమ్ వర్క్ చేసే ఇన్స్ట్రక్షన్ ఏమైనా ఉందా, వీ విల్ సెర్చ్ అండ్ వీ విల్ రీప్లేస్ ద ఇన్స్ట్రక్షన్స్. అది మెషిన్ డిపెండెంట్ ఆప్టిమైజేషన్. మెషిన్ డిపెండెంట్ ఆప్టిమైజేషన్ ఏంటంటే వెన్ ఎవర్ వీ వాంట్ టు ఆప్టిమైజ్ ద కోడ్, okay, if there are any instructions, we will try to replace those instructions with other instructions which are fast and which can do the same work. But when we come to the machine independent optimization, we don't touch the instructions. Whatever the instructions, they will be kept same as it is. We don't try to transform the instructions. We don't try to modify the registers. We try to modify the addressing modes. Or whatever the things which are related to machine, those things will not be modified. Only we will modify the statements which are related to programming language only. But in case of machine dependent, we will try to transform the statements which are related to programming language and which are related to machine instruction set also. The type of optimization is called machine dependent optimization, and the one where we don't touch the machine instruction set, the type of optimization is called the machine independent optimization. See that one once. This code optimization phase attempts to improve the intermediate code to get a better target code as output. Okay, machine independent optimization. This code optimization phase attempts to improve the intermediate code to get a better target code as output. This part of intermediate code which is transformed here does not involve any CPU registers or absolute memory locations. Okay, here this type in this phase of optimization, okay, it does not involve any CPU register. The registers will not be modified. Okay, memory address locations, that means addressing modes will not be touched, instruction sets will not be touched. That is the machine independent optimization. Clear? This code optimization phase attempts to improve the intermediate code to get a better target code as output. The part of the intermediate code which is transformed here does not involve any CPU registers. If any three-address statement contains CPU registers, it won't transform that line. If any CPU register contains addressing mode, if any three-address statement contains addressing mode, it don't touch that line. If any three-address statement contains instructions, machine instruction, it won't touch those lines. It will modify, transform only those intermediate code lines which does not involve CPU registers or memory locations. That type of optimization is called machine independent optimization. What is machine dependent optimization? Machine dependent optimization is done after the target code has been generated. This is done generally after the target code has been generated and when the code is transformed according to the target machine architecture. Here the optimization is done according to the target machine architecture. It involves CPU registers, it involves absolute memory references. Clear? This type of optimization is called the machine dependent optimization. That is the thing, machine independent optimization and machine dependent optimizations. The machine independent optimization is performed on the intermediate code. Machine dependent optimization is performed on the target code. After the target code is generated on the target code, the machine dependent optimization will be performed by considering the machine architecture. That means instruction sets, registers, addressing modes, and everything. But when we come to the machine independent optimization, it is done directly on the intermediate code, and in the intermediate code also it will transform only those lines in which absolute memory locations or CPU registers are not involved. These are the majorly two types of code optimization: machine independent code optimization as well as the machine dependent code optimization. Next, today's last topic is the types of transformations. ఇందాక వచ్చిన కాన్సెప్ట్ ఏంటి? టైప్స్ ఆఫ్ ఆప్టిమైజేషన్స్. అదే కాన్సెప్ట్ టైప్స్ ఆఫ్ ట్రాన్స్ఫర్మేషన్స్ మీన్స్ వీ హ్యావ్ టూ టైప్స్ ఆఫ్ ట్రాన్స్ఫర్మేషన్స్ ఆర్ దేర్: local transformation, global transformation. What is local transformation? Okay, if the transformation is performed within the statements in a basic block, if the transformation is performed within the statements of a basic block, the type of transformation is called local transformation or local optimization. It can be also be called as local transformation or local optimization. Clear? A transformation of a program is called local if it can be performed by looking only at the statements in a basic block. By considering only the statements in a basic block, if you perform transformation, that type of transformation is called local transformation. What is global transformation? A transformation of a program is said to be global if it can be performed by looking at the statements of the entire program. By considering all parts of the program, if the transformation is applied, that type of transformation is called global transformation or global optimization. Okay, global transformation or global optimization, local transformation or local optimization. These are the things, types of transformations. Okay, local transformations and global transformations. As we said, local transformations can be performed first. Many transformations can be performed at both local and the global levels. Generally, most of the transformations are performed in both local level and the global level. When we want to perform both, generally local transformations are usually performed first. After local optimization only, global optimization will be performed. This is briefly the today's concept of introduction of the code optimization. What are the types of transformations? Okay, this is the briefly the things.